Assalamu alaikum, Adab, ladies, gentlemen, and today's August gathering. Today, we all have gathered here to enjoy a seminar on a very timely and relevant topic, trends in aviation and space technology research. We all express our warm gratitude to you for sparing your valuable time with us and motivate us to accelerate us in our own field of interest. Our respected Chief Guest and Honorable Vice Chancellor will be present among us within a very short time. I cordially request all of you to take your seats and ensure that your mobile phones or other electronic devices are on silent mode. Thank you for your cooperation and understanding. We are now waiting for the arrival of the Chief Guest. We humbly request you to stand up when our Chief Guest will arrive. It gives us immense pleasure to extend our warm welcome to all of you at Bangabandhu Sheikh Mujibur Rahman Aviation and Aerospace University.
Our today's chief guest, Honorable Chairman, Additional Charge of the University Grants Commission of Bangladesh, Seminar Chair, Honorable Vice Chancellor, respected Pro Vice Chancellor, faculty members, and audience present. Assalamu alaikum. I am Isma Jahan Naj from Aeronautical Engineering, Avionics Department.
And I am Ayan Shah from the same department. It gives us immense pleasure to extend our warm welcome to all of you at Bangabandhu Sheikh Mujibur Rahman Aviation and Aerospace University. Our today's seminar is on Trends in Aviation and Space Technology Research, organized by the Department of Aeronautical Engineering, Avionics. We also have BSMRAAU, AI and Robotics Club as the youth partner and volunteer. Today, we have with us Professor Dr. Muhammad Alamgir Sir, Honorable Chairman, Additional Charge of the University Grants Commission of Bangladesh, gracing our seminar as Chief Guest.
Dear Sir, a warm welcome to our BSMRAAU. Your presence at our seminar is a momentous occasion that we deeply cherish and will be in our remembrance for our long time ahead. We would like to express our sincere gratitude to today's seminar chair, Honorable Vice Chancellor, Air Vice Marshal ASM Pokrul Islam, OSP, GUP, NDC, AFWC, PSC, GDP, for inaugurating this seminar. Also special thanks to our respected Pro Vice Chancellor, Air Commodore ATM Habibur Rahman, BSP, NDC, AFWC, PSC, GDP, and Seminar Moderator Dean of Aviation and Engineering and Technology, Air Commodore MD Moklisur Rahman, NDC, PSC. We would also like to acknowledge the presence of our distinguished speaker. We are here to share their expertise and knowledge with us all.
I am requesting the Honorable Vice Chancellor Sir for his permission to start today's program. Thank you, sir.
At the very beginning, there will be a recitation from the Holy Quran. For this segment, now I like to request Maulana MD Atar Ali to come to the stage.
Assalamu alaikum wa rahmatullahi wa barakatuh. أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. ولله ملك السماوات والأرض والله على كل شيء قدير. إن في خلق السماوات والأرض واختلاف الليل والنهار واختلاف الليل والنهار لآيات لأولي الألباب الذين يذكرون الله قياما وقعودا وعلى جنوبهم ويتفكرون في خلق السماوات والأرض ربنا ما خلقت هذا باطلا سبحانك فقنا عذاب النار। এরশাদ হচ্ছে, আর আল্লাহর জন্যই হলো আসমান ও জমিনের বাদশাহী। আল্লাহই সর্ববিষয়ে ক্ষমতার অধিকারী। নিশ্চয় আসমান ও জমিন সৃষ্টিতে এবং রাত্রি ও দিনের আবর্তনে নিদর্শন রয়েছে বুদ্ধিসম্পন্ন লোকদের জন্য, যারা দাঁড়িয়ে বসে ও শায়িত অবস্থায় আল্লাহকে স্মরণ করে এবং চিন্তা গবেষণা করে আসমান ও জমিনের সৃষ্টির বিষয়ে। তারা বলে, পরওয়ারদিগার, এসব তুমি অনর্থক সৃষ্টি করনি। সকল পবিত্রতা তোমারই, আমাদিগকে তুমি দুজকের শাস্তি থেকে বাঁচাও। সাদাকাল্লাহুল আযীম। আসসালামু আলাইকুম ওয়া রাহমাতুল্লাহি ওয়া বারাকাতুহু।
To commence the ceremony, I warmly invite our Honorable Vice Chancellor, Air Vice Marshal ASM Fakrul Islam Sir, to present his welcome address.
Bismillahirrahmanirrahim. Honorable Chairman, University Grant Commission, Professor Dr. Mohammed Alamgir, and esteemed torchbearer of research and education of our country, respected faculties from the BUET, respected guest, Pro-Vice Chancellor, Dean of the faculties and staff of BSMRAAU, my beloved students, the future space explorer, members of the print and electronic media, Assalamu alaikum and very good morning. Very good afternoon. At the very inception of my speech, I pay deepest homage to the father of the nation, Bangabandhu Sheikh Mujibur Rahman. Bangabandhu incepted and developed Bangladesh as an independent nation. He wanted people in Bangladesh to be technologically developed, skillful, and place emphasis on creating new pro-science educational policies. To meet the dream of the nation, to develop the skillful citizen, and also to meet the gaps of aviation and aerospace, it was Honorable Prime Minister Sheikh Hasina who enacted the law of Bangabandhu Sheikh Mujibur Rahman Aviation Aerospace University, in short BSMRAAU, and established it in 2019. It gives me enormous joy as we could convert our nation's dream and bring it to the reality. Ladies and gentlemen, I'm thrilled to extend a warm welcome to each of you, and as we come together for the Trends of Avionics and Space Technology Research Seminar, an event being organized by the Department of Aeronautical Engineering Avionics in our university, BSMRAAU. The momentous occasion signifies a remarkable step forward for our university, uniting us in a common pursuit of knowledge, exploration, and shaping of future enriched by advancement in avionics and space technology. We are deeply committed to continually organizing such events, aligning with Bangabandhu's philosophy of education and the imperative of indigenous capacity building for the progress of our beloved nation. Our collective efforts are dedicated to realizing the vision of our Honorable Prime Minister Sheikh Hasina, who aspires to elevate Bangladesh into a developed country and established it as an aviation hub for the year of 2041. In an era where technology is advancing at an unprecedented rate, it is paramount that we keep abreast with the developing dynamics of avionics and space exploration. This seminar provides a platform for the union of minds and to dive deep into the cutting edge of our advancement in these realms. I would like to extend my deepest gratitude to the distinguished keynote speakers who have graciously agreed to enlighten us and with their invaluable insights in this seminar. Your contribution and presentation have exemplified the significance and the impact of the seminar that such an event promises to deliver. In my role as Vice Chancellor of BSMRAAU, it is a source of immense pride and joy to witness the remarkable progress and unwavering commitment of our students and faculties to dedicatedly contribute, and especially in the fields of avionics and space technology. We have launched several projects by this time, such as PICO satellite program for Bangladesh, model rocketry, Rover 71, design and development of robot for space exploration, drone development, which are running currently and successfully. The Trends in Avionics and Space Technology Research seminar is a shining example for our dedication to pushing the frontiers of knowledge and progress in the space and technology, especially at Bangladesh. It's not just a seminar, it's a celebration of the intellectual prowess and collaborative spirit and that defines our BSMRAAU's vision and goal. I honestly hope that the participants who have joined here will harness the maximum benefit from this assembly and fostering collaboration and igniting innovations and scouting pathways for future research in our beloved country. I always wish, ladies and gentlemen, that this seminar be a beacon of inspiration, and may we all work collaboratively to push the boundaries of avionics and space technology and research in Bangladesh. And we also welcome everybody aboard, and yes, we also make a promise for the future to soar beyond the skies. I thank you honestly, and I ask all the participants, including my beloved chairman of UGC, who always help us by his umbrella and giving ideas, guiding us properly, and also the professors sitting in the front from our very reputed university, Buet, who are from our beginning, guiding us and helping us in shaping our pathways, and to the future generations sitting behind, who will really be at the torch of future on the space and aviation technology. You are the true mirror of ours. So continue hard work, inshallah. Through you, the Bangladesh will shine one day. Thank you very much. Joy Bangla. May Allah bless us all.
Thank you, sir, for your valuable speech and for delivering a compelling message to enhance the growth of our university. In today's seminar, we have participants from BSMRAAU. Additionally, this seminar was open to anyone who wanted to join online. There was a registration process, and here are the seminar statistics. We got almost 315 plus registrations from 51 universities.
Dear audience, now we move on to our first keynote presentation. The topic of this keynote is application of EM fields in aviation, a concern and mitigation about the high frequency EM fields imposed on flight crew members and passengers. Now we are requesting our program moderator to give a short biography of our first keynote speaker.
Bismillahirrahmanirrahim. Our first keynote speaker is Professor Dr. Ajay Krishno Sarkar, Professor of Electrical and Electronics Engineering at Rajshahi University of Engineering and Technology, Ruwait, Bangladesh. about short biography of the speaker. After completing his BSc in Electrical and Electronic Engineering from RUET, Professor Dr. Ajay Krishno Sarkar has received his master's from Japan. He obtained his PhD in Electronic and Computer Engineering from Griffith University, Australia. He is currently serving as professor in the Department of Electrical and Electronic Engineering at RUET. He is also member of Teachers Selection Board at different universities in Bangladesh. Dr. Sarkar is a reviewer of several journals such as IEEE Access, IEEE Photonics Journal, Computers and Electronics in Agriculture, etc. His research interests include sports and biomedical engineering, photonic crystal fiber and biosensors, microwave and RF circuits and devices. Without further ado, may I now request Dr. Ajay Krishno Sarkar to join us on stage to share your experience. Sir, floor is yours, sir.
I am delighted and very honored to be speaker of this seminar. Very distinguished professor, my respected teachers, my harbingers, actually I follow them, some teachers from BUET and some of the faculty members of this university, respected Vice Chancellor Sir, Pro-Vice Chancellor Sir, and my beloved student who are the main stakeholder of this seminar, of this university, and the further. So as the short biography, Sir mentioned some of my qualification, actually not qualification, still I am in learning phase. Yesterday, when I was waiting for the train at Tista Junction, I was learning the magnetic exchange criteria, how the sound signal is being connected to one station to another station. And that was very old. I was telling those guys that we could have very smart communication system. Still, they are using the British, whatever British established in this country. So, without further delay, I'm to deliver my presentation. Is it time to deliver my presentation, or I need to just say something? Presentation, okay. So actually RF absorption and microwave absorption, I started at Japan, that is 2002, where I did masters. I did masters in microwave absorption. Then later on, after having PhD from Australia, I focused on RF devices also, because RF devices, most of the people in communication, in housely held devices, and many other areas or arenas, people are using RF devices. Microwave absorption mainly for microwave ranges frequencies, but RF devices are mostly liable or mostly effectual to the health, because microwave cannot penetrate through the body, rather RF penetrate. Although in the low range of microwave, signal can penetrate the body. Today's topic is actually, I mentioned about the RF absorption in aviation. Though I don't much idea about the aviation, what are the instrument or what are the vicinities, but I have some research findings I want to share with you. And actually, some of my students got degree from RF and microwave absorption, master's degree. One is trying for PhD research. So first of all, I want to focus about the title. The title composed of EM field in aviation. Of course, EM field is everywhere. The concern is about RF absorption. Those people are very closely proximate to the EM field. What are the health concern and how to mitigate this thing? So first of all, it will be better for me because I need to see the slide. So first of all, I would like to say some phenomena or tell some phenomena. I don't know whether it would be very relative to this presentation, but people need to know actually what is EM field, how it is producing, and what are the sources of EM field, and what are the criteria, how it affect the health well-being of the people. So these are everybody. Everybody knows actually those who are related to electrical and electronic engineering. EM field actually electric and magnetic phenomena, and those are coming from the electric flux and magnetic flux. And I think, is it working well? Please. Oh, yes, sir. Okay, sorry about that. Okay, these are the things actually. Application of EM field. Everybody knows in microwave antennas, electric machines, satellite communication, bioelectromagnetics, electromagnetic interference and compatibility, electromechanical energy conversion, radar, meteorology, and remote sensing. Actually, radar, meteorology, and remote sensing, those are very much applicable in aviation actually. And also the communication field, electronic communication or RF field communication, using the RF field or microwave field. It is not working well actually. It is taking some time. As a percent, please, next. Next slide. There are some application of EM field. First of all, physical medicine in the form of EM power that will heat up any tissue that need to be heated. Say some tumor or some cancerous tissue, or some of the cancerous tissue need to be heated up, and some of the tissue need to blown up. These are the things. And then induction heaters for melting, forging, annealing, and surface hardening. And dielectric heating, actually in shortwave, in form of shortwave, we use electromagnetic field. Next slide, please. Then interesting is that EM field is being used in agriculture. For example, please click on the to change the vegetable taste, we can use EM field. Sometimes I say to my student, say you don't want to take too much vegetables because the vegetables not taste good to your tongue. If I impose an electromagnetic field, it will feel you like a goat meat. It could be happened. And some sort of electromagnetic field can characterize the soil characteristics, say content of the soil water, evaporation level of the soil, some of the chemicals level in the soil. Then EM field also include some of the devices. Those are well known to our student or to us. These are the transformers, electric relay, TV, telephone, and so on. Please, next slide. Now, what is EM field? everybody knows, I think, what we are sitting, whoever is sitting here. Actually, EM field coming from the great law by Coulomb. When two charges are apart from each other, they experience a force to each other. And this is Coulomb law. In 1785, he devised the law. And please, next slide. And this is the mathematical expression. The EM field is the force per unit charge. When two forces are apart from each other, they exert force on each other. And force on each charge or of a unit charge is known as electric field. Please go on the next slide. Next. Next. This is the equation of BL field. E equal to F by Q, or the per unit charge. Next. 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 I want to skip those slides. These are too much theoretical. Next. These are the thing actually. What could be the form of charge? Actually, they could be point charge, surface charge, or line charge. And different devices have different sort of charge. Next, please. Next, please. Next, please. Stay here. Now, I want to say electric flux. What I ever said, that electric flux and magnetic flux is formatting the electromagnetic wave. And electric flux, that is first determined by Michael Faraday in his experiment. He found he was using two spheres, concentric sphere, and he charged one sphere, and he grounded another sphere. And later he found that that was grounded, that got a charge. And that is the starting of the charge and ending of the charge. Next, please. Next, please. Next, please. These are the explanation I have written down. I want to skip those texts. Then, stay here. Michael Faraday found that the outer sphere is also got a charge, meaning that there is the continuation of the charge, whatever he imposed on the positive sphere. Then he concluded that there is a displacement of the charge, and that displacement in is known as electric flux. Next, please. Next, please. Then Michael Faraday told to the people that actually whatever charge is, how much charge is, that is equal to the electric flux. Number of charge equal to number of electric flux line. Next, please. This is the experimental evidence of Michael Faraday. Next, please. Next, please. Next, please. Next. Next. Then, what is the relation between electric flux and electric field intensity? It is related to the property of the medium, that is called permittivity. Permittivity is the property of a material, how well it can having the electric flux through it. And it is related to electric flux equal to permittivity multiplied by electric field. Next, please. This is Gauss' law actually. Gauss, whatever Michael Faraday did in his experiment, mathematically Gauss proved that electric flux equal to electric charge. Next, please. Now we want to know the magnetic field, because electromagnetic wave is composed of electric flux and magnetic flux. Next, please. This is coming from Biot-Savart law. This law actually magnetic field due to a current carrying conductor. We know electric field is due to charge and magnetic field is due to current carrying conductor. And my Biot have stated, next please, that field is proportional to the current carrying the conductor, length of the current, and distance of the point from that wire or current carrying conductor. Next, please. And this is the two important law, Ampere's circular law and Maxwell equation. That is the main thing to get the EM field or plane wave for EM field. Next, please. Next, please. Next, please. Now, as we see, electric flux, electric field, and electric flux density is related to permittivity. In the same way, the magnetic field and magnetic flux density also related to a physical property of the medium. That is called permeability. Then we know two property of the medium, permeability and permittivity. That is the property that characterize the wave, that characterize the velocity of the wave, dispersion of the wave, reflection of the wave, and a lot of things. Next, please. These are the Maxwell equation. I think everybody knows those very well. These are the integral for Maxwell equation. Actually, Maxwell did. Actually, he took three equations from three people. One is Michael Faraday, another is Ampere, and another one is Gauss. And Maxwell not only proved those equations, he also did the mathematical foundation. And I want to say about something Maxwell. Einstein told, if Maxwell will not born in this world, I will not be the Einstein. So talent he was. Einstein told Maxwell is unparalleled talent for this globe. Next, please. This already I told. Law of Michael Faraday, law, Ampere law, and Gauss law. Those are the constitution of Maxwell equation. Next, please. Now, these are the thing actually, EM wave, whatever we are having problem with that. First of all, I have shown how EM field is applicable for our beneficial object or beneficial effect. And now I will say the detrimental effect of EM field. This is the equation derived from Maxwell equation. This is called Helmholtz equation. Who derived this equation? Then from this equation, the solution of this equation, we are getting the equation of electromagnetic field. That is the wave of electromagnetic field, plane wave. Next, please. These are the time harmonic equation. From this equation, we can determine the velocity of the wave, reflection of the wave, even penetration depth of the wave through a human body. Next, please. These are the pictorial view of EM wave. Electric field and magnetic field are perpendicular to each other, and they are in the perpendicular to the direction of propagation. I mean, this is called TEM mode, TEM mode, transverse electromagnetic mode. Electric field and magnetic field are perpendicular, and also they are perpendicular to the direction of propagation. Next, please. This is the animated view of electromagnetic signal. Whatever the signal is transmitting from the antenna, these are the form. Electric field and magnetic field are perpendicular to each other, and they are flowing out of the plane where they are lying together. Next, please. This is the power. Actually, when electromagnetic field penetrate or any receiver receive that field, it got a power. That is electromagnetic power. And that electromagnetic power is coming from the pointing vector. Pointing drive this equation. Next, please. That is total power. Whatever power is escaping from an antenna, that is equal to the Please go to the previous. Yeah, stay here. Last one. Stay here. Yeah. The total power, actually, rate of decrease of electromagnetic energy and ohmic loss, minus ohmic loss. Next, please. This is the pictorial view of how power is calculated by pointing in his theorem. Next, please. Now, actually, those are, I already told, those are the theoretical thing actually. I don't know whether these were wise to me to include in this slide. The main thing is coming here. That is in aviation, the sources of electromagnetic radiation. These are the devices that radiate electromagnetic wave. These are the ADF. I think these are well known to everywhere, every people who are working in aviation. ADF, area nav, ATC transponder. Next, please. DME, ELT. I don't want to say the elevation because time is short. I am supposed to finish within half an hour. Maybe I will take more. ELT, electronic conspiratory devices. And next, please. Next, GPS. Next, safe communication. This communication across the pilot to the ground station. That is high frequency communication. Next, please. These are the marker. Actually, these are beacons. Actually, next, please. Then radio altimeter, satellite communication, SBS. Next, please. And those are the things actually. Next, please. Next, please. Please skip this. Now, actually, what is electromagnetic radiation? And actually, what we are measuring to assess the doses of absorption in the body. Next, please. Actually, when a person or any conductor, we are a great conductor, human body is a conductor, is positioned in an electromagnetic field, then there is a current induced on that device, in that device. And that current depends upon the property of the body. And from that current, we know where there is a current, there is a heat, and that heat actually affects our body. And we are actually measuring the heat. And that heat is coming from the specific absorption rate, SAR, a parameter that is the matter of research. That is the interest of research. The parameter, we are having research with that parameter. How SAR value, how SAR of this device, how SAR is induced in that body. Please, next, please. Next, please. Next. This is the SAR, a specific absorption rate, and it is related to electric field. Next, please. This is SAR. It is the time derivative of the incremental energy absorbed by or dissipated by a object. Time derivative of incremental energy, and it is related to electric field and mass density and also conductivity of the body or object. That is here, sigma is the conductivity, E is the electric field, and rho is the mass density. Mass density means how much kilogram or gram within a volume. Next, please. Next, please. Then our interest is here. Del T, that is the elevation of temperature by the electromagnetic absorption. When body absorbs electromagnetic wave, there is a temperature rise. And that temperature rise is very crucial or very naive, some of the organs. not all of the organs, especially nervous system. Nervous system is very prone to that temperature rises. Next, please. Next, please. Next, please. Now, stay here. People having research with the whole body absorption and local absorption. What is whole body absorption? That is predicted throughout the body as a average value. And local absorption is for a particular limb of a body, say eye, say lung, say heart. Next, please. And this is the, please stay the curve. Please, yes. Back, please go back. And this is the curve, whole body average energy absorption rate. And the two curve, one is for man and average for, next one is for mouse. And exposed power, please go stay. Exposed power is 1 milliwatt per centimeter square. When the man is exposed, 1 milliwatt per centimeter square power. Power means power density. Whatever we are getting from the antenna, that is actually power density, power per unit area. And we see the two curve is from an animal and also a people, man actually. Next, please. And I want to show the body who are concerned about the absorption and who have formulated some policy, some measure to protect the people from this hazard. These are the UNEP, IRPA, and WHO. These are the well-known organizations. Everybody knows them very well. Next, please. Now, interesting is that what are the frequency ranges that affect our body? This is actually frequency below 100 megahertz that are more detrimental to our health, rather micro ranges. Because micro ranges cannot penetrate through the body actually. Because our body is a conductor and microwave or electromagnetic wave cannot penetrate through a conductor. Next, please. Next, please. Now, I want to say some health consequences for this microwave RF absorption. These are the, some people did work very, very long ago and some recent work as well. Next, please. They are actually several effects of our several limb. Say we are talking about the whole body absorption. These are the thermoregulatory adjustments, meaning that when a body is absorbing RF frequency power, their thermoregulatory system get affected. It is being adjusted. What is meaning adjusted? It is deviating from its original or right way. That is, it reduces the metabolic heat production, also vasodilation. It induces the vasodilation. Vaso means the tube from which the blood is flowing. So dilated means something expanded. When RF absorption is happening through the body, then our metabolic heat production is reduced. What is metabolic rate? We know. Whatever we are eating, we are getting the energy, that is the metabolism. And vasodilation create the low blood pressure. If the channel or pipe of the blood is becoming enlarged. Next, please. Please go next, previous slide. Previous slide. Yes, there are some transient effects. These transient effects include reduced performance of the learned task and increased plasma corticosteroid level. Corticosteroid level. What is corticosteroid level? Actually, these are related to some hormonal network related thing. Some hormone getting decreased or getting increased from the RF absorption. Please go next slide. There are some other heat related hazard, that is temporary hematopoietic. Hematopoietic something related to blood. That the reduced red blood cell level and immune response, some immunity will be destroyed from that heat effect from the RF absorption. And this is due to the elevated corticosteroid level, that is our hormonal system, this term related to. And most consistent effect is circulating lymphocyte, increased level of neutrophils, altered natural killer cell or macrophage function. I think those are many of us knew the terminology. I have some written the terminology. What are those actually? Actually, lymphocyte. Lymphocyte is some of the organs within our blood. Go to next slide, please. Next slide, please. This is the thing. First of all, hemostatic process is thermoregulation. Thermoregulation is the process, is a hemostatic process. Hemostatic means that is, it can correct or it can adjust by itself. That process will be disturbed because whenever we are affected by any germ, bacteria or viruses, sometimes our body get fit without taking any drug. That is the coming from the homeostatic process. And corticosteroid process is hormonal related thing. That is the decrease of steroid hormones. Steroid hormones will be decreased. And what are the function of steroid hormone? Is the genetical thing. That is, I will tell later. Next. And more interesting is that senescent cell, when the RF absorption getting within our body, the clearance of senescent cell is get reduced. Actually, what is senescent cell? Senescent cell are those cells, those already being actually matured. They cannot be broken up. Every time or each time, our body cell is breaking and making together. So senescent cell, those are cells that those breakdown have already halt, and our body actually remove this cell from our body. Then we got we got healthy, or we got any we got rid from any other health hazard. And those, if the senescent cell exists within our body, those form the cancer. So those cell is stopped, break down. The body remove those cell in the stream of blood or stream of urine, or in the stream of other thing that is excreted from our body. Next, please. Next, please. Next, please. Now, due to our RF absorption, there are some localized responses. What happened to your body? Happened to the reproduction system, that is genetical system, will be destroyed. And research found that, I will show later, some people who have a long position very close to the RF devices have destroyed their genetical abilities. Next, please. For example, in 1959, Baron et al., he reported childlessness অর্থাৎ means that the male person is affected from their genetics abilities, and this person, Lanza Cardon, they found decreased in sperm count, and when they found also same thing for exposing microwave field. Next, please. This is the transgenetic effect, and this called transgenetic effect means when a new baby is formed, that is the embryo and fetus, those are affected by the RF field. Next, please. Next, please. Now, effect of eye. Some research found that due to RF absorption, our eye got heated. If eye got it heated, then sufficient blood circulation is hampered to the eye. Then there's some optical effect in our eye. Next, please. And some numbness is also there. Numbness means অবশ, and that is happening to the RF burn, also RF absorption. Research found those. Next, please. This is related to cancer. As I am telling that if our body can't remove out the cell, those got halt, those cannot be divided, they already saturated in division, then this happened. This is they transformed into cancer cell, and this has happened to the RF absorption if the heat affect the nervous system. Next, please. These are the recent work. I have shown the previous work very long ago, and these are the recent work. These people work on several flights, and they actually measure the value of electric field component, electromagnetic wave, electric field, and they found the maximum value even 3.307. That is also detrimental. I'll tell later what are the doses or level that is not harmful to the body. Next, please. These people in 2021, that is Joanna et al., they recorded maximum value of the electromagnetic field 10.6 volt per meter from a omnidirectional radio, and they checked it in a number of flights, and those flights name are there. Next, please. Next, please. Please go your slides. There are three situations. One is a person is very close to the RF device without having the ground, and another person is close to the RF device standing with the ground. Next, please. And this is the person who is within a reflector, and that is happening to the pilot actually, because pilot is surrounded by the thing or object that electromagnetic is reflected, and that is the very concern and very harmful actually, because when the electromagnetic field is reflected from another plane, it is superimposed and it got higher value. What was the original dose or exposure was? Next, please. And this is the difference, grounded and ungrounded. that is the who are standing over the ground and close to the RF devices, they got the higher value of the absorbed power actually. Then if somebody is not standing with the ground or some wearing something that is not touching the ground, there is no connection of the leakage current through the ground, then it is more safer than standing within the ground. Next, please. These are the guidelines, very well-known authority, ICNIRP. They guide some occupational exposure level for safety of the human health. That is 0.4 watt per kg at frequency range 10 to 10 megahertz. And for head and neck and trunk, they suggested the SAR value should not be exceed 10 kg per 10 watt per kg. And other part of the body, they suggested 20 watt per kg for a 6-minute exposure within a 10 gram tissue. Next, please. And this is the thing I wanted to mention. What is the value or level of the field? That is 10 megahertz, 10 to 100 megahertz frequency. The electric field 60 volt per meter. Unperturbated magnetic field 0.16 per meter. That is 0.2 Tesla. And body current to ground 100 milliampere. Meaning that if body current is 100 milliampere through the ground, it will not affect, or still the people could survive. Next, please. And these are the control actually. A lot of control is there. Just I mentioned few of those. One is, these are the from the body or authority, and then employer, some responsibility of the worker, some responsibility of the manufacturer. This is important because I am holding my mobile in my pocket and very close to my heart or lung. Then mobile phone company should ensure that SAR level is within the safe limit. Next, please. And this is the maintenance procedure, some work practice. What we need to do actually. Some maintenance procedure, operation procedure, and identification of RF hazard. Next, please. And these are the installation to protect in RF hazard. This is unshielded. As I told, there are many of methods to protect from RF hazard. I mentioned only one, that use a shield. And this is the unshielded cabinet. Next, please. And this is the shielded cabinet. This is the shielded, the scratch line are shielded line. Next, please. This is the shielding procedure. I don't want to mention very details because of time constraint. And actually, the voltage generator is having or working in such a way that when the device is producing the RF and that is liable to the body, it is getting it to the ground. Next, please. And these are the cross section of the shielding cabinet. Next, please. And this is the reference. So thank you very much. I intend to tell more actually about it, but I think half an hour is not sufficient. A lot of things I just skip. So thank you very much again to giving me the opportunity to say something in this dais. And I hope students will do research in this field. I like this field from my master's level. I did the microwave absorption, not in body, but superconductor in Japan. Thank you very much. Have a nice day. Please. Question answer, I missed that, sorry.
Sir, thank you very much for your well-delivered presentation. It was really informative, inspiring, and truly enlightening presentation on the topic. Now it is the house is open for question and answer session. Now I request or encourage our student to ask some question.
Waalaikumsalam. A very nice question. There could be some shielding that could be placed within the, if I say for the pilot in the cabin. And also not only within the flight, but also the crews, even the ground station, those people are working in the very close to the tower, very close to the transponder, very close to the receiver. Those have the hazard too. And that can be shielded. I did not mention about more about the shielding policies or shielding technologies. Have you got my answer? Okay.
Next question.
As we already know, we have some data against the solar radiation like ozone to protect us. My question is, can we use this type of gas as shielding to protect us from radiation?
Okay, a very good question. Actually, there's some research. Those are the cosmic radiation. Research about the cosmic radiation. Because whenever a flight is very high, it gets some radiation from the cosmic object, say sun. So we can use ozone to protect the radiation, but there is some problem to set some apparatus or some protective devices using ozone. Are you talking about the ozone? Okay.
Due to time constraint, we'll take one more question.
স্যার আপনি মনে হয় কিছু বলতে চাচ্ছেন? Okay, sir. Thank you.
Both the questions that have been asked. Actually, the aviation instruments and aviation platform are made in a safer way, considering the radiation. Whenever the pilot is put in, the cockpit is so designed or organized that the radiation are put into the wing and to the absorption level of the human. So there is better autonomy of the aircraft and this radiation and RF, what do you call it, emissions are so controlled. And it fixes to a safer. At the same time, in the other operation area, wherever the ADF and other are placed, transmitter, they are also the working stations are in the safer. So in aviation, all sector, whenever you innovate, you also keep in mind that if there is radiation, if there is emission, then as we put it to the minimum level to the human tolerance and long support. Besides that, if you are having to expose, then you have to dress yourself to minimize those exposure. Like whoever goes to space, they wear space suits, and that is especially made to meet those challenges. So whenever people fly above the pressure level, they wear pressure suits. So at the same time, whenever you enter to such technical area, you are that kind of school which has gone and looked after this radiation and other adverse effects that could cause harm to the individual. So this research, I think, have brought our mind, opened our mind that in future innovations, we should be all aware to bring those items to human society. Thank you.
Okay, thank you very much.
Now, we would like to show a short glimpse of the student innovation activities at BSMRAAU. We are thrilled to showcase the incredible innovation initiatives led by BSMRAAU students. Among these initiatives, the standout ongoing project is the PICO Satellite for Bangladesh project, which focuses on the indigenous development of PICO satellites, also known as CubeSats. I would like to invite Saurabh Bashak, team leader of the Electronics and Power System team of PICO Satellite for Bangladesh project, to join us on stage and provide an overview of the project.
Hello, honorable guests, Vice Chancellor Sir, Pro-Vice Chancellor Sir, respected deans, respected faculties, and fellow students. Firstly, I would like to thank you all for giving me the opportunity to present one of the most successful and innovative project of BSMRAAU, Pico Satellite for Bangladesh. Myself, Saurabh Bashak Joy from Avionics 1. I am currently the team leader of Electronics and Power System team, and will guide you through this presentation. So if we want to know that what is Pico Satellite for Bangladesh? Pico Satellite for Bangladesh is a joint research initiative of BSMRAAU and PicoSat company of Bangladesh, along with A2I, with the tagline, Future of Space Program in Bangladesh. Our MOU has already been signed between BSMRAAU and Pico Satellite for Bangladesh on March 2022. The objectives of the projects includes international collaborations in research fields and development of CubeSat, as well as creating research ecosystem for the students at BSMRAAU. You will be amazed by the fact that the global market of CubeSat is projected to be valued at $491.3 million by 2027. This creates an opportunity for us to create the pathway for Bangladesh to achieve its own space economy. To achieve these great milestones, we are working in teams to put our best into it. Our teams includes mechanical team, electronic and power system team, control, communication and navigation team, ground station team, and finally the software team. Within a very short span of time, we have achieved several milestones. First of all, the automated ground station system, which consists of unidirectional antenna with an automated tracking mechanism built into it. Additionally, we have collected data sets from few satellites. We have captured images and signals from NOAA 18. Keeping track of it, we had also submitted a paper to the International Conference of Next Generation Electronics in India on development of ground station with an automated satellite tracking system. And I'm very glad to announce that the paper has already been accepted. This is an incredible start to our journey towards excellence. Our next big milestone is the assembly of CubeSat 2.0. With the guidance of our collaboration star, Dr. Nazmulullah sir, we have assembled our first CubeSat. This little orbiter is a space-grade satellite capable of transmitting and receiving signals from hundreds of kilometers with its own communication system powered by the solars. Honorable Vice Chancellor sir has already appreciated our achievements and provides his valuable insights to take our projects to new heights. And we want Honorable Vice Chancellor sir to hold a CubeSat just like that, solely developed by the students of BSMRAAU. And to fulfill this mission, we are on a mission to develop indigenous development of one new CubeSat by 2024. That's all. Thank you.
Thank you, Shoro Bosha, for your wonderful presentation. Now, another remarkable project developed by BSMRAAU students in the BSMRAAU's Rover 71, an interplanetary explorer. This project aims to create a Mars rover, a robotic spacecraft dedication to studying the surface of the planet Mars, the fourth planet from the Sun in our solar system. I would like to invite Taisi Ninad, leader of the Rover 71 project, to deliver his presentation.
Assalamu alaikum everyone. Myself Taisi Ninad from Avionics Fast Batch and also the team leader of Team Revolution. At first, I would like to thank our chief guest, our Honorable Vice Chancellor and Pro-Vice Chancellor Sir, respected Dean and faculty members, the students and all other participants for joining in this marvelous event. Today, I will discuss about a project that will have a positive impact on our students as well as the university. The Rover 71 project is such a project that BSMRAAU one day will have its own Mars rover that can represent in front of the world. Before going to the deep, we all should know what is a Mars rover. A Mars rover is a robotic spacecraft specially designed for exploring the Martian surface. To make this dream into reality, we already have the support of the authority of BSMRAAU. In this presentation, you will all have an overview of the engagement of people who are leading in this project from both the back and front. The sole aim of this project is to design and build a next generation Mars rover, which will work one day alongside with the human explorers and also will compete in different various Mars rover competitions all around the world. Now the question arises, how do we get the motivation to initiate this project? As we can see that different universities from Bangladesh are not just participating, but also securing honorable positions in the international Mars rover competition. As we can see, Team Interplanetar from Buet and MIST Mongol Barta from MIST have already owned a Mars rover, which can represent themselves in front of the world. Not only them, but also Team Anirban from IoT and BSMRAAU Mongoltori from BRAC University have also joined in this competition. Now the time has come where we should join the legacy. Here we can see an approximate 3D model of our rover. The name of our rover will be Rover 71, which I have mentioned before. The objective of this project will be to explore the Martian surface, which will aid in the development of technology. Not only that, it will also inspire and engage students in STEM education. Also, it will represent our university in the different aspects of competition. It will also serve as a platform of innovative solution. Last but not the least, it will also contribute to the global effort of human and space exploration. To achieve these objectives of this project, our team has already divided into 5 sub-teams: electronics and power system team, mechanical team, software team, science and environment analysis team, and admin team. After designing and constructing, it will have some unique functionalities. The pictures which I have shown is got some in from internet sources. First of all, it can perform some several tasks such as traveling through rough terrains, delivering equipment from one place to another. It all will also able to conduct some scientific experiment such as soil, rock, water, and other chemical testings. It will also withstand in the harsh environment, which is a vital factor to explore in the Martian surface. Team Revolution has already set a goal to have their own Mars rover within 2025, and inshallah, we believe that we can achieve this goal. Thank you for your valuable time and consideration. I hope to see you all next time. Allah Hafiz.
Thank you, Taisin Inath, for your insightful presentation. We are sincerely excited and immensely proud of the students' effort in PICO Satellite for Bangladesh project and the Rover 71 project. We all hold hopes for the success of the Student Center projects guided by the experienced faculty members of our university.
Now I would like to welcome the moderator of today's seminar, Air Commodore MD Mokhlisur Rahman, Sir, the Dean of Aviation Engineering and Technology, to share his valuable speech. So I am requesting Sir to come to the stage.
Bismillahirrahmanirrahim. Respected today's seminar chief guest, Professor Dr. Mohammad Alamgir, Chairman, Additional Charge, University Grant Commission. Seminar Chair, respected Vice Chancellor, BSMRAAU, AAU, respected faculty members from BUET, eminent key speakers, distinguished guests, and my dear students. Assalamu alaikum and very good afternoon. It is an absolute pleasure and honor for me to welcome you again in today's exciting event, that is the Trends in Aviation and Space Technology Research Seminar. The seminar offered us a unique opportunity to gain insights of the latest development of aviation and space technology. Our distinguished guest speaker shared his valuable knowledge and experiences and gave some valuable perspective on the rapidly evolving landscape of these sectors. I hope we have achieved the aim of the seminar. Our first keynote speaker was Professor Dr. Ajay Krishno Sarkar from RUET. Congratulations, sir, for your well-delivered presentation. Your presentation was both educational and captivating, and obviously truly enlightening on the topic, application of electromagnetic fields in aviation, a concern and mitigation about the high-frequency EM fields imposed on pilot. Your expertise on the topic provided us valuable knowledge. The presentation explored the application of electromagnetic fields in aviation, specifically addressing the potential concerns arising from high-frequency electromagnetic field affecting human body. We have also highlighted the application of electromagnetic field in agriculture sector, where it can change the property of vegetables also. We have also mentioned different sources from where these electromagnetic fields are generated and their possible impact on the pilot and onboard passengers' health and safety. We have also highlighted some mitigation strategies to address and alleviate those concerns in the aviation industry. Sir, indeed, your presentation was informative and engaging. Our second keynote speaker is Mr. Sakir Hossain from our university, from our in-house. His topic is interference management in UAV assisted wireless network. He will deliver his presentation later on. And we have also our third keynote speaker. This is Dr. Rokonuzzaman from Monash University, Malaysia. He will be connected later in virtually. Ladies and gentlemen, the pursuit of knowledge and innovation is a long journey that knows no boundaries. But through this seminar, our junior scholar, that is our student, have got chance to make a network with the professionals, engaged in discussions, and stay updated with the latest or cutting edge advancement in this sector, that is aviation sector. And obviously, this will elevate our university in shaping the future. And then the last, I'd like to give my earnest thanks to respected chairman, additional charge, UGC for arranging the seminar as a chief guest. Special thanks to our seminar chair, the respected Vice Chancellor, for being with us. And thanks to respected guests from BUET and other those who are present here. And also thanks to the seminar organizer. Thank you all. Joy Bangla.
Thank you, sir, for your valuable speech and direction. Now, we have a special session for all of you. We are delighted to share that today's youth partner, BSMRAAU AI and Robotics Club, organized its first inter-university event, Circuitry Challenge 1.0, from August 10 to August 24 in 2023.
The primary objective of this event was to identify talented students who possess an interest in solving electrical circuit-related problems and to increase enthusiasm among the students in building up their practical knowledge for future project works and igniting their passion. The event commenced with a registration process. All students of BSMRAAU were invited to take part in this competition.
Here are the registration statistics for the event. There were a total of 81 participants who participated in 2 categories. After 2 rounds of competition, both theoretical and practical, a total of 8 participants are being awarded.
Now, I would like to request our Honorable Chief Guest, Professor Dr. Muhammad Alamgir Sir, Honorable Vice Chancellor, Air Vice Marshal, ASM Fakrul Islam Sir, respected Pro Vice Chancellor and Chief Patron of BSMRAAU, AI and Robotics Club, Air Commodore ATM Habibur Rahman Sir, come to the stage to hand over the prizes to the winners. The total number of participants for this circuit was 81 students. Upon successful competition, we got 8 students from 2 categories. In the intermediate category, first prize goes to MD Tariqul Islam, Avionics second batch. Second prize goes to MD Rafi, Avionics second batch. Third prize goes to Kahid Nur Rahman, Avionics first batch.
In the basic category, the winners are: first prize goes to Mohana Chaudhary, AE Avionics third batch. Second prize goes to Tajikur Rahman Turjo, AME Aerospace first batch. Third prize goes to Niyaz Morshed Nihal, AE Avionics third batch. Fourth prize goes to MD Miraj Hossain, AE Avionics third batch. Fifth prize goes to MD Burhanuddin, AE Avionics fourth batch.
Now it's time to hand over seminar crest to our honorable chief guests and respected speakers. I would like to request our chief guest, Professor Dr. Mohammad Alamgir sir, to hand over crest to our first keynote speaker, Professor Dr. Ajay Krishno Sarkar sir. I again request our chief guest to hand over the crest to our second keynote speaker, Dr. MD Sakir Hossain sir. Our third keynote speaker, Dr. MD Rokonuzzaman sir, is not present here physically, so we will send him the crest. Now I further request our chief guest to hand over the crest to our respected Pro Vice Chancellor, Air Commodore ATM Habibur Rahman sir.
I again request our chief guest to hand over the crest to our Honorable Vice Chancellor, Air Vice Marshal ASM Fakrul Islam sir. Now, I would like to request our Honorable Vice Chancellor Sir, Air Vice Marshal ASM Fakrul Islam sir, to hand over the crest to our Honorable Chief Guest, Professor Dr. Mohammad Alamgir sir. Our chief guest, Professor Dr. Mohammad Alamgir sir, is present with us. He is the chairman.
Our chief guest, Professor Dr. Mohammad Alamgir sir, is present with us. He is the chairman, additional charge of the University Grants Commission of Bangladesh and former vice chancellor of Khulna University of Engineering and Technology, Kuwait. Now I warmly request the chief guest to share his experience and thoughts about today's seminar.
Good afternoon. I am actually very happy to be here for the first time in my life in Lalmonirhat, one of the wonderful place. And this is a wonderful weather. And now it is not the time to deliver the speech, very hard. I know that everybody will be very happy if I make very brief speech. And Honorable Vice Chancellor, Air Vice Marshal ASF Fakhrul Islam, the Pro Vice Chancellor of this university, all the faculty members, officers and employees, esteemed scholars, scientists, dear students, and mainly the keynote speakers and our guest from Buet and all other guests. It is indeed a pleasure for me to share few moments expressing my opinions and views about several things. Firstly, I would like to thank the organizer, Department of Aeronautical Engineering of Bangabandhu Sheikh Mujibur Rahman Aviation and Aerospace University for organizing this groundbreaking seminar, Recent Trends in Avionics and Space Technology Research. I am very happy to see that the venue of this seminar is not in Dhaka. It is in Lalmonirhat. My opinion, it is a remote place. If I compare it in terms of distance and communication from the capital. And also last night it took several hours to come here with a very busy street and lot of trucks in that street. I never thought that it is so busy with the trucks. But this is a wonderful place where the permanent campus of this university will be established. I am sure. And it will develop in such a way in future, it will be one of the best campus, not in the context of Bangladesh, but also in the global context. I have seen the infrastructural master plan of this university because last month, probably University Authority has presented their master plan, and you may see on the first floor on the display. It will be an amazing master plan when it will be converted into the real things. This place has an historical importance as the university campus will be established in and around the Lalmonirhat airport, which remained almost abandoned from the independence of our country. And as you know that this airport was constructed during the British period in 1939 to 1940 over a massive area of Mahendranagar and Harati, Union of Sadar Upazila, which was used extensively during the World War II. This morning, I visited with the Vice Chancellor in that campus, and I found it is very fascinating, and I hope that it will be one of the best one. And I'm very glad that authority has decided to come in this campus. As a member of UGC, especially in charge of planning and development since 2019, and presently as the chairman of UGC as additional charge, I have witnessed the continuous progress of this university since its establishment in 2019. I do hope that the university will be able to accomplish the dream of Bangabandhu Sheikh Mujibur Rahman in contributing to for the development process of Bangladesh to build his dream Sonar Bangla. Dear audience, I would like to draw your kind attention that on last 29th October 2023, in a special convocation of Dhaka University, the Honorable Prime Minister Sheikh Hasina told in her speech as a convocation speaker that we established Bangabandhu Sheikh Mujibur Rahman Aviation and Aerospace University to take the country in a height of dignity in order to victory of the space. So this university has huge responsibility to accomplish the desire of our beloved Prime Minister and also to fill the aspiration of the people of this country who paid tax to run this university because this is a public entity. This country became independent with a huge cost. If blood is the price, Bangladesh paid the highest price ever to become the independent, with the sacrifice of 3 million peoples and the loss of most precious personal belongings of 200,000 women. So as a people of this country, we have huge responsibility to pay attention the people who sacrifice their lives for the independence of this country. As a new university, as well as dealing with a new specialization area, we had dream when we was the student, we learned about the aeronautical aviation, but we never thought that it will be a discipline in our country in a university, but this is now the reality. So there is a huge challenge for the university authority to materialize the goal of the university. Despite the initiative taken by the authority by arranging the teachers and resources from home and abroad, the main role should be taken by the teachers, researchers, and the students. As the academic and research advancement are the prime activities of the university, university is for the generation of new ideas, innovations, patenting the ideas of innovations, and thus customize it with the collaboration of industry and other entities, which is not an easy task indeed. It needs to develop a journey of dedication and achievements and the development of culture of research. Without this, we cannot accomplish our desire. The research plays a vital role to identify the future route to go to accomplish the goals. To this endeavor, one should know the route and destination. This can be achieved through the exchange of views and opinions among the researchers, which can be achieved through the seminar and symposium. I would like to thank the organizer for realization and also for organizing the event. And I especially thanks to Professor Ajay from RUET for presenting his interesting paper. And also I would like to thank the two students who expressed their hope and aspiration, Picoset and Robert 71. I wish to have a great success to this endeavor, and I wish a great success of your journey also. Dear researchers, in the age of rapid technological advancement, the field of avionics and space technology stand out as some of the most exciting and promising domains. We need to hold the key of numerous possibilities for this unprecedented development of wireless global communications through satellite, cyberspace monitoring and management, data acquisition and surveillance, to potentially unlocking the mysteries of our universe through space exploration. Bangladesh has already started to explore the area of space technology into its scientific advancement. Bangladesh became the 57th country globally to join the club of satellite with the launch of Bangabandhu Satellite 1 into the orbit in 2018. It has the plan to launch the Bangabandhu Satellite 2 very soon under the G2G agreement with Russia. So the establishment of this university is a timely initiatives. And I might appreciate, and I would like to thank the foresightness of our Honorable Prime Minister, who gave her special direction and order for the establishment of this university. Dear students, you have entered into a journey to reach the meaningful destination where bundle of opportunity have been waiting for you. It is a tedious path having a lot of challenges in every steps, but remember that journey of 1,000 miles begins with a single step. And I have seen your achievement, and I am very much happy to see this. And I also like to thank the authority. They have developed a good environment, especially the laboratory, classrooms, and other facilities within the shortest possible time. So far, I can remember that the history of the development of university, it was established in 2019. And by the year of 2023, the infrastructure achievement, although it is rented, but it is really appreciable. I would like to appreciate the tremendous efforts put for this achievement, the authority and this team who have been working since 2019. Thank you very much. And my dear students, the success at the university life requires two crucial aspects. Number one is the inside of classroom components, which comprises pursuing academic excellence and doing well in classes and exams. Don't forget it, you have to do well in classes and exams. It emphasizes rigorous courses and also the rigorous demands from the teachers. So you have to accomplish it. And number two is the rest of the experience, capitalizing the campus opportunities, which you have shown your PICO set and also Rover 71, and choosing extra curriculum involvement, managing time well, developing friendship, and vast array of other on-campus experiences. Please remember, the students learn 70% from outside of classroom, and they learn 70% inside the classroom. So you have to find all the scopes to develop yourself. These 4 years will never come in your life. So don't miss this opportunity. Dear researchers, now we are living in the era of 4IR, Fourth Industrial Revolution. The effects of 4IR is so versatile that every moment changes are occurring around us. The beauty and challenges in this 4IR era is that even one cannot imagine in what extent and scale the society and the planet will be changed. The changes are extensively related to the advancement in the research and development of science and technology. The 4IR emerged on a sharp contrast from the previous revolutions, for example, first IR and second and third, because unlike the previous one, where technology replaced the skilled workers, but in 4IR and beyond, the better worker or high skilled worker will replace the low skilled worker. So we have to develop our skill. There is no other way. And also there is a further beauty of 4IR is that there is an integration, that means fusion of technologies. Now it is not possible to go for the single-handed. We need the multiple discipline approach. I have seen that in your approach, you have also formulated 5 different teams also. This is the real approach. Collectively referred to the cyber physical system now, representing new ways in which technology became embedded not only within the society, economy, and culture, but also within human body and mind. This is the era in which, driven largely on the convergence of physical, digital, and biological innovations, there is no doubt that the future research, even in space technology, will be guided by such integration of these 3 phases. Today, I was discussing with our Honorable Vice Chancellor that in future, maybe people does not need to in the cockpit. There might be the robot and other and drone technology. Then he mentioned that drone cannot take a lot of load and weight, but I don't know in future it might be. So we have to think about this, that fusion technology also. Again, to meet the challenges of 4IR and beyond, graduates needs to have critical thinking. So you should consider to have the critical thinking and innovations, active learning, strategic creativity, originality, initiatives, leadership, and also your emotion. And you have to learn how to work in a group. That is very important in future. So UGC has been encouraging both the public and private universities to go ahead with such research. And because without innovation and research, we cannot think about the meaningful existence of a university. University is for creation of new ideas, knowledge, innovation, creating skills, and for the graduates and develop the time-breaking attitudes. The graduates needs to have the capability to work out of the box. We should not work inside the box. We should go out to see the possibilities, what we can do. And in this context, I would like to quote one thing, because if we do not change ourselves, we cannot exist, because it is important. Please remember that future is not something we enter, it is something we create. Because the things have been changing, so you should be adapted with these changes. Otherwise, you will be outdated. I can quote one of the famous quotation by philosopher Charles Darwin. He mentioned that it is not the strongest of the species that survive, not the most intelligent, but the one responsive to change. So we have to responsive to change, which will come present in future. I do hope that such initiatives will show the right way. It's like that your Pico set and Robert 71, the conference and all other things. Time and protect our future. I would like to thanks to all who worked very hard to organizing this wonderful seminar. Hope its continuation, and I assure that UGC always will remain with you. Finally, I would like to thank the authority working under the dynamic leadership of the Vice Chancellor for inviting, and also for inviting me and giving me the warm and cordial hospitality. Joy Bangla, Joy Bangabandhu, Be Bangladesh, live forever.
Thank you, sir, for sharing your valuable opinions and thoughts with us. Now, I would like to request our Honorable VC sir and respected Pro VC sir to hand over a special moment of our university. Now, I would like to request our Pro Vice Chancellor, Sir, Air Commodore ATM Habibur Rahman, sir, to deliver the closing remarks for today's seminar.
Bismillahirrahmanirrahim. Honorable Chairman of University Grand Commission, Honorable Vice Chancellor of Bangabandhu Sheikh Mujibur Rahman Aviation and Aerospace University, distinguished professors traveling all the way from Buet to our campus at Lalmonirhat, learned keynote speaker, and other keynote speakers online and will be delivering later. Distinguished participants, colleagues, and students. Assalamu alaikum and good afternoon. This is due for lunch, so I will follow the respected chairman. I will not make my speech longer. First of all, I would like to express my sincere thanks to our Avionics Engineering Department, which is in short, for arranging this wonderful session on trends in aviation and space technology research, which is one of the priority sector in today's research and development. I would like to express my gratitude to the participants and extend heartfelt thanks to the students who volunteered and who are from the AI and Robotics Lab to support this event. Today, we had the opportunity to dive deep into the domain of aviation and space technology research. Although it is the formal part is ending here today, but then the rest of the seminar proceeding will continue in a breakout session and will continue in parallel. That's how the best option that we had to manage the time that we have in hands, because to accommodate other events. The seminar created so far that what we had an opportunity for our students, faculty members, and experts to share their expertise, views, and opinions, and collectively enrich our understanding. The invaluable insight gained here will undoubtedly catalyze innovative research endeavors for young minds, leading to aviation and space technology advancements. The knowledge imparted and the connections forged during this seminar will serve as the building blocks for future collaborations. Undoubtedly, many pioneering projects will emerge from the seeds sown here today. And for that, I would like to especially thank our distinguished keynote speaker and other speakers who shared valuable insights with us today. The rapid development of aviation and space technology underscores the imperative of our commitment to continuously research and innovate. Today, the seminar has delivered profound insight into contemporary trends that span over several important domains. These domains cover utilizing electromagnetic waves within and beyond aviation sector, including our daily lives. The steadfast pursuit of sustainable energy solution in aviation and space exploration. And the other presentation, which includes the adept management of interference issues in UAV-assisted wireless network, and there are more. These pursuits extends far beyond the confines of academia, wielding tangible influence over societal well-being, the economic prosperity of Bangladesh, and the overall sustainability of our planet. We extend our sincere appreciation to the distinguished keynote speakers who graced the event with their experience and expertise. In this seminar, we must acknowledge the dedicated participation, the participants who all are more in number than the participants we have in-house here today from our university, whose unwavering enthusiasm and active engagement have fueled our success. Your presence here reflects a commitment to advancing knowledge in aviation and space technology. Here at BSMRAAU, we have several student-centric research projects ongoing. Few of them were displayed here today, like Pico satellite and rover. The other projects like rockets, like drones, and there are many others. They are ongoing, but then due to time constraint, we had to keep it limited to 2. The dedication of our student and faculty members will surely drive future innovation and research in these domains. I would like to extend a sincere thank again to the volunteer of AI and Robotic Club for supporting this program. Their tireless efforts have made this event a resounding success. A special thanks to the faculty members and staff of Department of Avionics Engineering, who took the initiative and made it happen so successfully. I am really proud of this team. I would also like to extend heartfelt gratitude to our esteemed chief guest, Professor Dr. Mohammad Alamgir sir, and our respected Vice Chancellor for graciously dedicating their time, traveling all the way from Dhaka to here and displaying a keen interest in our seminar and university activities and development. Your presence and encouragement have deeply inspired our students and researchers. Thank you, sir, for your invaluable supports. Finally, I would like to reiterate the vision of our father of the nation, Bangabandhu Sheikh Mujibur Rahman, in developing Sonar Bangla, which inspires us to work hard for the development of our motherland. We have to realize that we are playing the most important role in this vision. And I firmly believe that we are slowly but surely fulfilling the dreams of our father of the nation. Let's continue to push the boundaries of knowledge and innovation, ensuring a brighter future for all of humanity. With this, I end my presentation. May Allah help us in every possible way. Joy Bangla. Thank you, sir.
Thank you, sir, for sharing your important opinion and thoughts with us. Now I request our honorable chief guest, designated guest, and nominated student to come to the stage for a photo session. Thank you, everyone. Dear audience, our chief guest will be leaving the seminar now. Our seminar has not ended yet. I request everyone to be seated. Now we move on to our speakers. Dear audience, please be seated. Our seminar has not ended yet. Dear audience, please be seated. Our seminar has not ended yet.
Hello, hello.
Hello, sir.
Hello, sir. Rokun sir, are you online? Hello? Hello?
Assalamu alaikum, Samin. Yeah, I'm here. I can hear you.
Dear audience, now we move on to our second keynote presentation. The topic of this keynote is Sustainable Energy Research in Avionics and Space, Exploring the Skies and Beyond. Our second keynote speaker is Dr. M.D. Rokonuzzaman sir. Here is his short biography. Dr. M.D. Rokonuzzaman sir is a senior lecturer, researcher fellow at the School of Engineering, Monash University, Malaysia campus. Before joining Monash, he worked as a research officer at the Institute of Sustainable Energy at the National Energy University UNITEN, Malaysia for 4.2 years.
He has served as an assistant professor and the head of the Department of ECE at ISTT, National University of Bangladesh, a lecturer at the Department of Electrical, Electronics and Communication Engineering, EECE, in MIST, as a sessional academic at the Department of ICT at Bangladesh University of Professionals, BUP. Dr. Rokon was awarded a PhD in engineering from UNITEN, Malaysia.
He is a distinguished building opportunities, Living Dreams Bold Scholar, and was honored with Bold Strategic Higher Fellowship from 2018 to 2022. He received an MSc in EECE and BSc in Tripoli. His research interests include artificial intelligence, IoT, smart grid, energy management, space energy, and solar PV application.
Dr. Rokon has been awarded a total of 8 international medals, including 1 gold medal and 1 bronze medal in MTE 2022. Malaysia, 1 silver and 2 bronze medals in the ITEX 2021 Malaysia, and 3 silver medals at SIIF 2021 South Korea. He received the Best Paper Award at the 8th SCHEMA 2014. He has also filed 3 patents and published more than 40 research papers in WOS, ISI, Scopus Index International Journals. Now we are directly connecting with our third keynote speaker, Dr. M.D. Rokonuzzaman sir, in online.
Assalamu alaikum. Can you hear me?
Sir.
Assalamu alaikum. Can you hear me?
Sir, please share your presentation here.
Okay.
Sir, we can hear you clearly.
Is it hanged?
Yes, sir.
Just a second.
Sir, have you
shared the presentation?
Yeah, I
Sure.
shared, but I think it's hanged already. Just a second, Samin.
So is it hanged on your part, sir, on your side or our side?
I'm not sure. Let me check.
Okay, sir. Copy আছে না?
Slide?
So we have a copy of your presentation here. So when you will
No,
say
it's
next,
okay. It's
we will
okay.
change the presentation.
No,
If
it's
that's
okay.
okay, then sir, we will share.
Let me share my one.
না এখানে বলতে হবে জি স্যার Sir, should we share your presentation from our side?
Just a second, Samin. I'm trying to share my one. My system may be hanged.
Okay, sir. Thank you, sir. We are seeing the presentation. Yeah.
Assalamu alaikum. Sorry for the inconvenience caused just now. So can I start?
Yes, sir. You can start, sir. Thank you, sir.
Bismillahirrahmanirrahim. Assalamu alaikum and very good afternoon. I'm truly delighted to be invited here. Welcome you all to this talk on sustainable energy research in avionics and space, exploring the skies and beyond. Today we embark on an interesting session exploring into the cutting-edge advancements and innovative solutions in the fields of sustainable energy research on aviation and space technology. Thank you for joining us today. I am thrilled to provide you with an overview of this presentation, which is structured as follows. First, I will introduce myself briefly. Next, I will explore into sustainable energy and its impact on aviation emissions. These factors have been crucial in supporting our research in this field. Following that, I will discuss the effects of greenhouse gases on aviation fuel consumption, offering tangible evidence of our research influence. Additionally, I will highlight various sustainable energy technologies for aviation and space, which have not only influenced our research, but also depended our understanding of the field. Finally, I will share my vision for the future, exploring the opportunities for Bangladesh in space and energy. Thank you for your attention, and I am eager to engage in meaningful discussions and collaborations with all of you today. I'm currently affiliated with Monash University School of Engineering in Malaysia campus. Before my current role, I worked as research officer at the National Energy University of Malaysia. Currently, I am supervising 2 PhD students, 1 master and 1 undergrad student in Monash University. I have also mentored 4 master students from Malaysia, China, and Indonesia, and supervised 20 undergraduate students in Bangladesh. My research has led to around 40 publications in international journals and conferences. I'm proud to have received 8 medals from Malaysia and South Korea, including a prestigious gold medal at Malaysia Technology Expo 2022. My research interests revolve around artificial intelligence and the Internet of Things to enhance energy systems, efficiency, and sustainability. I am also passionate about advancing space energy research and power optimization, including the cloud energy storage. I am a professional technologist and a senior member of IEEE USA and a member of IET UK. In our rapidly changing world, the Sustainable Development Goals, or SDG, are a testament to our commitment to creating a better world, one where the environment, society, and the economy are interconnected and balanced. This interconnectedness is vividly illustrated by the SDG wedding cake model, where each layer represents a facet of our global development goals, with the environment as the foundational layer supporting society and the economy above. When we talk about sustainable aviation, we delve into a multidisciplinary field that seeks to find solutions to mitigate the environmental and societal impacts of air transportation. Aviation has long been an essential part of our global connectivity, but it has also been a source of concern due to its significant contribution to climate change. Sustainable aviation aims to reshape the future of air travel by reducing aviation's carbon footprint through new practices and radical innovations. This means looking for alternative sources of energy, cleaner fuels, and more efficient aircraft designs. It also involves improving air traffic management and reducing waste in the industry, all while maintaining the highest safety standards. In the world of commercial aviation, the dominant energy sources is fossil-derived aviation turbine fuel, or ATF. Jet A and Jet A1 are the standard fuels used, and they are primarily composed of hydrocarbons with carbon numbers ranging from C8 to C16. When these kerosene-type fuels are burned in the powerful engines of aircraft, they produce a range of emissions, including various gases that can have a significant impact on our environment and society. These emissions are not to be taken lightly. They have far-reaching consequences, as illustrated in the first figure. The effects are not limited to the atmosphere. They affect the very fabric of our society, as depicted in the second figure. One of the most critical aspects is the radiative forcing impact, often referred to as the greenhouse gas effect. This phenomenon directly links aviation emissions to climate change. As we know, climate change poses a substantial threat to our planet, affecting everything from weather patterns to sea levels and much more. I want to shed light on a critical aspect of our environmental concerns, the greenhouse gas impacts of various emissions, particularly in the context of aviation. It's important to note that many non-carbon dioxide emissions in the aviation industry have uncertain environmental impacts, but their anticipated effects are even more potent than those of carbon dioxide. This is a cause for concern and underscores the complexity of the issue. One of the key factors that sets aviation apart from other modes of transportation is the high altitude flying of commercial aircraft. This unique aspect has a profound impact on environmental sustainability in aviation. At these altitudes, the interactions of emissions like nitrogen oxide and water vapor led to the formation of aviation-induced cloudiness. This phenomenon significantly distinguishes aviation's impact on the environment. These effects not only have local implications, but also affect the global climate. They underscore the need for a comprehensive approach to address the environmental challenges posed by aviation. It's a complex issue, but one that we must tackle collectively to ensure a more sustainable and environmentally responsible future. I would like to talk about a significant challenge in aviation markets and fuel consumption. in the world of aviation, the prices of aviation turbine fuel are unstable. These price fluctuations pose a constant challenge to airlines, leading to unpredictable operating costs. These fluctuations are often closely tied to global supply variations, which are influenced by a myriad of factors. It is evident that the aviation industry faces an urgent need for a more sustainable energy source. Such a source should not only provide cleaner energy, but also offer cost predictability, reducing airlines' dependence on the unpredictable global events that affect ATF prices. Also need to develop a sustainable solution for transport class aircraft due to their significant fuel consumption. As it is clear from the second figure, is that to meeting their high power and energy demands is a formidable challenge. These are the sustainable energy technologies for aviation and space. Among them, liquid hydrogen, solar and battery technologies are expected to play a vital role in the coming days. Sustainable energy options is, while promising, face limitations in aviation due to low specific energy and safety challenges, such as thermal runaway incidents observed in battery electric aircraft like the Boeing 787. In comparing aircraft fuel costs to electrical energy costs, it's crucial to note that fuel prices fluctuate while electrical energy costs tend to rise with inflation, and weight differences significantly impact battery electric system. What powers a spacecraft does use? A spacecraft rely on three primary power sources. One is the sun, batteries, and unstable atoms. Engineers carefully select the power source based on the spacecraft's mission, location, and duration of the operation. Solar-powered aircraft represent a cutting-edge solution in the aerospace industry, offering environmental friendliness, extended flight durations, reduced operating costs, and quieter operations, making them a sustainable alternative to traditional planes. Solar power is a cornerstone of space exploration and satellite technology, offering an unlimited, reliable, weight-efficient, and long-lasting power source for over 90% of operational satellites in orbit, reaffirming its pivotal role in space missions. In the near term, 2021 to 2025, the aviation industry is focused on advanced materials, electrification, and incremental progress in autonomous flight systems to pave the way for greener and more efficient air travel. In the mid-term, 2026 to 2030, we anticipate exciting developments, including hydrogen-powered aircraft, the revival of supersonic travel, advanced artificial intelligence co-pilots, and an increased focus on sustainable aviation fuels, shaping the future of air travel for efficiency and sustainability. Last few days, I conducted some searches and research on the space and energy scopes for Bangladesh. I conducted searches across 3 databases. One is Google Scholar, Scopus, and Web of Science. And if I'm not mistaken, I couldn't find any existing research on the topic of sustainable energy research in avionics and space in Bangladesh. Here, the same term I used in searching Google Scholar, there is no similar publication has been published yet. In Scopus, I searched with the same terms, and it is showing that no documents matching your keywords were found. That means maybe till now, there is no publications have been published based on these keywords, including the space and energy and Bangladesh. Similarly, in Web of Science, I also did not find anything. Just I found one paper in 1998. It's titled as Needs for Space Technology for National Development in Bangladesh. It's written by one Indian scientist. So this indicates a significant gap in the current research landscape. Therefore, I firmly believe that we are at the inception of a promising journey with substantial research opportunities in this field. There is a vast and unexplored scope for conducting research and making valuable contributions in this area, opening doors to new insights and innovations based on Bangladesh, based on space, energy, and aviation sectors from Bangladesh. Here are the references I used to prepare this presentation. These are my normal presentations that I prepared for this one, but I have some more slides that I want to share with the teachers, faculty, and students here. So in currently we are doing some research. These are the highlights. We are working on the smart home or home energy management system. Home energy management system is an intermediary device that visualizes, monitors, and controls residential power uses. We developed an energy management system for smart homes that are integrated with artificial neural network-based solar photovoltaic system. We also developed a self-communicative smart plug and self-sustainable wireless sensor network node based on smart IoT as part of the smart community environment. A successful prototype of the energy generating pad, which is named as EZP, is developed under the National Science Foundation USA project in Malaysia. We have been received the fund for 11-kilometer bike lane in Kuala Lumpur city. So it consists of thin film piezoelectric cells connected to an energy collection circuit, creating a 7-layered energy generating pad. This project aims to create a blockchain-based peer-to-peer energy trading model for congestion management and power loss reduction in existing power systems with distributed energy resources. Traditional centralized models are being transformed, allowing prosumers to exchange excess energy, including solar generation and demand reduction, using IoT devices. Energy storage and cloud energy sources are explored to enhance efficiency, while blockchain technology ensures transparent, secure, and cost-effective energy trading. An algorithm is proposed to optimize the peer-to-peer energy trading and manage grid congestion. This research supports rooftop solar prosumers in energy trading and benefits consumers and utilities. This project is funded by Petronas Research Sudan Barahat. This is a 3 years project. This is our upcoming research. Honorable guests and dear audience, North Bengal in Bangladesh faces the severe impacts of climate change, including floods. To ensure the urban population's survival, we must embrace innovative solutions. We can employ satellite IoT and artificial intelligence to predict and prepare for climate-related disasters, particularly floods. Drone-based agriculture aids in effective flood water management, while drone and satellite-based smart farming optimizes urban agriculture, reducing pressure on rural areas. These technologies offer a sustainable model for urban survival in North Bengal, especially the district Kurigram, the Upazila Chilmari, Lalmonirhat, allowing us not only to adapt but to thrive in the face of climate change challenges. This project is preparing based on the National Science Foundation USA. They are guiding us to prepare the things to develop a sustainable model. This is our current research achievement. Our team won second prize in the Green Practice Challenge Accelerator competition in USA, which is under IBM Call for Code 2022. I supervised, I was the one of the team member as supervisor of the team Transect Energy. This display is showing the current team members and the local and international collaboration moments from our Malaysian teams. Here are team effort and outcomes, top international collaborators and upcoming publications are presented. Over the last few years, we have been collaborating with Professor Saifur Rahman from Virginia Tech, USA, Professor Mithulan from the University of Queensland, and Professor Shuza, an NSF collaborator from Texas A&M System, USA. Few parts of our research have been recognized from different international exhibitions in Malaysia and South Korea. As one of the potential innovations, the prototypes achieved a total of 8 medals, including 1 gold medal in Malaysia Technology Expo 2022. Thanks a lot for your kind attention. That's all from my side. It's done, Samin.
Thank you, sir.
Yeah.
Thank you, sir, for delivering us information about this topic, which is a key factor to develop in the future. Dear audience, if you have any question for our speaker, the floor is open for you.
Assalamu alaikum, sir. I'm Mubin
walaikum
Azam from Aeronautical Engineering Avionics Batch 3. Sir, as you have said that we use solar energy on spacecraft such as satellites. My question to you is that what kind of renewable energy source we can use on aircraft that operates in our atmosphere?
Thank you so much for your nice question. Actually, till now, it's proven that solar cell is one of the best and prominent renewable energy sources that are vastly using in spacecraft, even the space stations. So till now, solar is one of the best option, but nowadays hydrogen fuel cell is one of the alternative is growing up. So I believe that hydrogen fuel cell is also be an alternative very soon.
Thank you, sir.
Assalamu alaikum, sir. I am Saidul
Walaikum
Rahman,
salam.
Avionics 03 batch. My question is about what are the key challenges in implementing sustainable energy solutions in avionics and space exploration?
The point is key challenges.
Yes, sir.
It's a nice question. Though I am not expert on avionics, but personally I feel that at the beginning, primarily we should have proper knowledge based on the research. If the research is enough, if the exploration is enough, then the challenges will be mitigated. At least we can understand what is the coming problem and how to solve. So for now, in the perspective of Bangladesh, the key challenges is the research and development team, is the research and development expertise. So for now, based on Bangladesh, I feel that the environment to do a good research, to do some exploration on avionics, sustainable avionics, based on the other goals, it is crucial and it is more challenging compared to other parts, other things.
Thank you, sir.
Yes.
Assalamu alaikum, sir. I am Ahad Ishrak. Sir, I want to know how we can integrate drones and satellites together for smart farming in agricultural section.
Thank you so much. Is that Ahad?
Yes, sir.
Can you please repeat the question again?
Sir, I want to know how we can integrate drones and satellites together for smart farming.
Satellite and drones. Oh, that's a good. That's a great. Okay. So as the basic concept, already Bangladesh have the satellite, own satellite, right? As an aviation university, I believe that in some days, your university will have their own satellite station. For now, in this current stage, we can take the help or coordination from the space agency, like Bangabandhu satellite or other outside in outside of Bangladesh. They can help us to directly connect the satellite communication to our drone. We know that drone is flying not too much altitude, so the drone communication, the satellite, we must need a permission from the satellite agency to access their network, which will be directly connected to our drone. So in this moment, to do the communication with satellite and drone is to have the permission from the satellite agency. Then the drone will do the rest. Drone will can do the area mapping. Area means the land we are using for farming. The drone can mapping this area. The drone can use the landscapes for image processing. The drone can use the sensor data to measure the dryness of soil, the necessities of the things we used for fertilizers. So drone can be collected the sensor data from the land, and the climate changing thing or predicting thing, we can have the data from satellite based on the previous or historical data. So both can communicate in this way, and we can accommodate a drone and satellite for smart farming. Is that clear for you?
Yes, sir. Thank you, sir.
Yeah, thank you so much.
Thank you, sir. Now, I would like to request our distinguished Professor, Air Commodore MD Afzal Hossain sir, to remark about this presentation.
Assalamu
Thank you
alaikum.
very much. Welcome, salam. Thank
Yeah.
you very much, Dr. Rokonuzzaman,
Yes,
for
sir.
your very enlightening presentation, thought-provoking presentation. The three
Thank you, sir.
questions that was raised by our students were very intelligent questions. Particularly the last question was much more insightful.
Yes, yes,
Dr.
Prof.
Rokonuzzaman, we say sorry for keeping you holding for a long time because of the chief guest was from his chairman, so we had to adjust many things. So
It's okay, Prof.
we cut sorry figure for to you, but I would request you to be connected with our university. And these enthusiastic students, they are second year students maximum, and they are so enthusiastic. I would request the students also to know his link from Assistant Professor Samin. Keep in touch with Dr. Rokonuzzaman. He is a man from this locality, and he is a very outstanding researcher. And his area of research is very well aligned to your study. So, like the last question raised by Ahad, drone and satellite, how can be communicated to have impact on agriculture? So it's a 80% of a research proposal is done through his question. So
Yes,
he
sir.
can do the research. He will come to Bangladesh sometimes. So we shall discuss it on further, that collaborative research undergraduate students even can be taken under him. Anyway, I'm not going to elaborate your subject matter of your topics. Once again, thank you very much. And
Yes, Prof.
please do be connected with our university.
Yes, Prof.
And do visit our university
Yes, Prof.
whenever you get chance and visit Bangladesh. Please visit our university and interact with our students. Thank you
Yes,
once
Prof.
again.
Inshallah. Yeah,
Your
thank you so
crest,
much, Prof.
seminar crest, and your souvenir will be kept with Assistant Professor Samin.
Yes,
So please do come and collect and interact with the students. Thank you.
Yeah, thank you so much, Prof. One more
Thank you,
thing, just
sir.
I want to add, the students here or the young faculties can connect with me. I can help them by doing some research collaboration or research guidance. So don't worry to be communicated with me. So just email me. I can share my knowledge. I can share my expertise. So it will be very nice and fun to learn together. And it will be a great pleasure for me to serve this university. Thank you so much. Assalamu alaikum.
Thank you once again, sir, for giving your valuable time and connected with us from Malaysia.
Yes. So can I leave now?
Yes, sir. Thank you so much, sir, for your time.
Yes, I mean, thank you so much. Assalamu alaikum.
Assalamu alaikum, sir.
Now, we move on to our third keynote presentation. The topic of this keynote is application of interference management in UAV assisted wireless networks. Our third keynote speaker is Dr. MD Sakir Hossain.
Here is a short biography of our third keynote speaker. Dr. MD Sakir Hossain is an academic and researcher specializing in wireless communication and security. He received BSc and MSc degrees in Information and Communication Engineering from the University of Rajshahi, Bangladesh. He obtained his PhD degree in the field of wireless communication from Saitama University, Saitama, Japan.
He is currently working as an assistant professor at the Department of Avionics Engineering at Bangabandhu Sheikh Mujibur Rahman Aviation and Aerospace University. Before joining BSMRAAU, he was an associate professor at Department of Computer Science, American International University, Bangladesh. In 2019, he worked as a postdoctoral researcher at Czech Technical University, Prague, Czech Republic, where he focused on research in interference management for unmanned aerial vehicle assisted wireless networks.
His current research endeavors revolve around the development of new waveforms and beamformers of integrated radar and communication system. His research interests span a wide spectrum, including UAV assisted wireless networks, integrated radar and communication systems, machine learning assisted wireless network, and development of malware intrusions detected system. Now I kindly request Dr. MD Sakir Hossain sir to join with us on stage and share his keynote presentation.
নাম তো ভুলে গেলাম তুমি একটু শোনার সাথে okay it's work now. Yes, thank you all. Thank you all for joining this seminar. Today, I will talk about the interference management in unmanned aerial vehicle assisted wireless network. Actually, when I was requested to present or discuss a topic in this seminar, I was trying to find a topic that will go with this seminar and a topic that I can easily explain in front of those people who are not expert on wireless communication or who has no experience in working with wireless communication. So I found one of my paper that is closely similar with the actually theme of this seminar, and I think it will be easier for me to explain everything of this algorithm that I'm going to present today. So This is the content of my presentation. I will start my presentation with a brief introduction on 6G communication system. Then I will discuss about the concept of AV assisted wireless communication, which will be followed by the algorithm that will be developed, that is developed for managing interference caused in AV assisted wireless network. Then I will present a low complex solution assisted by some algorithm. And finally, I will conclude this presentation giving a future research direction. So this is a trend of traffic volume. We see that just 3 years back, the traffic volume per month per user per month was only 5.3 gigabyte. Okay, but just after 3 years, it is now 18 gigabyte per month. Okay, actually it has increased by 3 times, and we see that at the end of 2030, it will be 257 gigabyte per month. This means the traffic volume requirement per user per month will be multiplied by almost 50 times. So this is a huge challenge for the researcher of communication engineering to meet this demand. So there is another challenge. We see that in 2020, the number of smartphone subscribers was 1.3 billion, and it will be 5 billion at the end of 2030. Okay, and the most important thing is machine-to-machine communication. It's a new concept, and we see that just almost 10 years back, it was only 0.213 billion machine-to-machine devices in the world. But right now it is 7 billion, and at the end of 2030, it will be 97 billion. So it's a huge, I would say, exponential increase of the number of machine-to-machine type device. So we see that it's an emergence of traffic producer. It's a huge emergence of traffic producer. This machine-to-machine type devices will require 622 exabyte per month, which is 2,429 times of the traffic demand right now. Now question is, how can we meet this huge traffic demand within next 7 years? It's a huge challenge. And the people of this sector, that is communication engineering, must come up with solutions. So to meet this demand, researcher has started working on 6G wireless network. Right now, the research of 5G is completed, and it is in a phase of implementing in different countries. And in most of the developed countries, they have already implemented 5G of different standard. Okay, and 6G research has already started. And right now, we are at this point where the vision of 6G research has already been developed. And this is developed by International Telecommunication Union. And right now, we are working on setting the requirements of 6G wireless network. Okay, and ITU is doing right now. And then at the beginning of 2026, we start working on the evaluation of all the techniques that will be developed by this time duration. And once the requirements are set, third generation partnership project. Actually, this organization is responsible for developing standard based on all technologies that will be developed by this time. So they will first study all the research that will be done up to 2027. Then after studying all the latest inventions, they will start specifying the standard. And it is estimated that the standard will be developed by or finalized by 2027, no, 29. And then we'll go to the deployment. Okay, now we will see, even if we are just finishing finalizing the vision of 6G research, but most developed countries have already started working on this research. First of all, Finland's Oulu University developed their 6G research lab, and then China kicked off their 6G research plan, followed by Japan, and Next Generation Alliance is formed by USA, and recently South Korea has published their 6G research plan. But question is, what we have developed or what we have done so far to prepare ourselves for 6G research? Actually, still now, we are only the consumer of technologies. But to implement our national goal, we have to transform our nation from technology consumer to technology producer. Okay, so we have to take some plans nationwide to contribute in this research. Next, we will talk about the requirements that we have already set by this time. This is not finalized requirement. This is the requirement of 6G research that we have set so far. It will be updated over time. We see that in 5G, the user experience data rate is 0.1 gigabyte. And we estimate that it will be multiplied by 10 times in 6G. That is, per user, the data rate that it will experience will be 1 gigabyte per second. Okay, and in addition, the latency will be improved by 10 to 100 times lower. Okay, and spectrum efficiency, this means the number of bits that can be sent per hertz wave will be increased by 5 times. And in addition, mobility is very important from our perspective. Why? Because if we want to access internet staying in aeroplane, then mobility will become a very important issue. And it is estimated that the mobility of 6G will be twice the current mobility. Currently, 5G support 5 kilometers per hour, this speed. Okay, as long as the speed of a user stays within this range, then there will be no degradation of performance. But in 6G, we assume that 6G network should support more than 1,000 kilometers per hour. This is a very crucial point of 6G research from our perspective, from this university perspective. So we should develop some plan to develop new algorithm that will enable us to support or enable us to develop some technologies that can support this huge mobility. In addition to this requirement, there are other requirements like coverage, then positioning. In 5G, positioning accuracy actually changes in meter level, usually 5 meters. That is, if it says that position is here, it may change 5 meters in that way, or that way. But in 6G, it is estimated that positional accuracy should be in centimeter level. It's also a very important research topic from our perspective. Then bandwidth should be 10 times higher, and followed by globally ubiquitous connectivity. That is, we must develop technologies that will enable us to connect to the rest of the world, staying anywhere in the world. Okay, so to meet this requirement, some technologies are being thought that these technologies will play a crucial role in 6G research. What are those? First is terahertz communication. Why? Because I have already mentioned that the bandwidth requirement should be 10 times higher, but the millimeter wave or microwave that is already completely occupied, and millimeter wave is being used in 5G, but millimeter wave will not be able to support 10 times wider bandwidth. So we have to go to higher bandwidth, higher frequencies, which is terahertz frequency. Then holographic beamforming, 3D networking. This is quite a new topic. And then integrated sensing and communications and visible light assisted communication. This is also a very new topic. And then wireless energy transfer. It is estimated that these technologies will play a very vital role in 6G. And our today's lecture will concentrate on 3D networking, basically. So what is 3D networking? It's a methodology where base stations or transmitter can be deployed in three-dimensional space. Normally base stations are deployed in two-dimensional space, okay? But a new dimension has been incorporated, that is height. It is height, okay? This enables us to integrate satellite network, UAV network, and terrestrial network, okay? And this extra degree of freedom that we can achieve due to height of the transmitter enable us to support global coverage and seamless connectivity. So from now on, I will concentrate my lecture on UAV assisted wireless network. Let us see a scenario where we see a concert and a stadium and a mass gathering. One thing is common in all these picture or scenario is that huge gathering of people for a short period of time. Okay, huge gathering of people for a short period of time. In this scenario, actually, people like to go to live telecast, okay, live streaming, something like this. So these require huge bandwidth. But we know that every base station has its limited capacity. And that capacity is actually programmed depending on the people located in that region and their profession. Nobody will plan that maybe 30,000 people will gather here for 20 minutes, so or 1 hour, we have to support them. So to support this huge number of people, our conventional network will fail. Their capacity will run out. So how can we solve this problem? We need to develop a system that will enable us to support this huge number of users for a short period of time. So one solution can be installing a high-power base stations having wider bandwidth so that we can support all users. But it is not economical from the point of view of I would say operators, mobile operators. Why? Because if we install a new base station near a stadium, then in most of the time of the year, these base stations will remain unused. Okay, so they will not set up such kind of base station. So setting up a base station is not a solution. So let us see another example. Due to man-made disaster like war, that is what is going on in Gaza, or natural disaster, the communication system may collapse. But for first search and rescue operation, we need to actually set up the communication system as early as possible. But we know that installing the conventional communication system will require several days, if not weeks. Okay, so how can we set up a communication system within few hours to support the fast search and rescue operations? This is another challenge. To solve this problem, both of these problems, we can use a new technology which is called UAV assisted wireless network. In this method, we mount a base station on a drone or unmanned aerial vehicle, whatever we say. And base station mounted UAV is called flying base station. This because this base station can fly from one place to another. So if we have any huge gathering like this, we'll just fly some drones, and this via the front hole, this drone will communicate with users, and via back hole, it will communicate to nearby base stations with a dedicated frequency. So we do not need to change anything in conventional communication system. So whenever we require, we will only set up this drone. We will only send this drone to the required place. And then drone, because since the drone has higher transmit power, so whatever your mobile phone cannot do, the drone will be able to do that. Okay, so now we will talk about this flying base stations challenges, because if this is a new technology, so if we want to make it viable, we have to solve some problems or challenges associated with this kind of communication. The first challenge is drone actually follows users. Okay, drone will go those places where there is higher user density. This means if we deploy multiple drones location will not be fixed since they follow users. This is the first problem. Since drones locations are not fixed, so conventional resource allocation technique cannot be applied here. Second is, since the drones locations are not fixed, so inter-site distance, this means distance between two base stations, will not remain same. It will sometimes two drones come closer depending on user density, and sometimes they go further. Because of the change of inter-site distance, the downlink interference will be severe sometimes, particularly those users who are located in cell edge area. Is there any marker? No. Particularly those users who are located farther from a base station will experience more interference. So they will experience lower data rate. So now question is, how can we solve this problem? In case of conventional communication network, since base station positions are fixed, so we can easily change the transmit power for those users who are located farther from the base station. But this is not viable for wireless drone etc. wireless network. So to solve this problem, actually this kind of problem in conventional communication network, we usually use short frequency reuse. Short frequency reuse. So in this case, a cluster of 3 cells are formed first. Okay, and each cell is divided in 2 parts: 2, 4, 8, 16. This kind of numbers. So I am showing here 2 parts, and this part is called cell edge region, and this is called cell center region. And the whole bandwidth is divided into number of subparts, and these subparts are allocated to these cells in such a way that each cell has its unique spectrum in the cell edge region. Each cell has its unique spectrum in its cell edge region. Have a look here. We have allocated this spectrum here, this one here, this one here. So each cell has different spectrum in the cell edge region. But when B1 is allocated to the cell edge region, the rest of the subbands is allocated to the cell center region. Here we see B2 is allocated to the cell edge region, while B1 and B3 are allocated to the cell center region. And the bandwidth that is allocated to the cell center region will have lower power. And this spectrum will have higher transmit power. So since it gets higher transmit power, so it gets higher data rate. But since we are using this frequency B2 here, it is further from the cell edge of the nearest band, it will experience lower interference power. This is how interference is reduced in case of soft frequency reuse. As for example, we see that this bandwidth gets higher power in cell 1, while it gets lower power in cell 2. This mechanism is used in fixed cellular system, that is conventional cellular system. But this method can only be applied in fixed cellular system when you have a predefined network layout. Because we know that in conventional cellular system, base station location is fixed, tower is fixed. So an RF engineer can easily allocate in spectrum in different cells, just observing the whole layout. But this kind of allocation cannot be performed in UAV network. Why? UAV's location will constantly change, and moreover, UAV's I would say cell area will also change. Sometimes it will expand, sometimes it will shrink, depending on the user density and depending on the nearby, I would say nearby UAVs. So each UAV will compete themselves among themselves to actually maximize its own throughput. So to solve this problem, we have to change the resource allocation scheme. So conventional resource allocation scheme cannot be applied to UAV assisted wireless network because of the fluid nature of the network architecture. So now let us see an example of the solution. First of all, we'll talk about user association. Suppose this user are associated with this UAV. Now, which user will associate with the cell center and which user will be associated to a cell edge? The conventional distance-based user association will not work here. This is why we propose to use received signal frequency, received signal strength as a measure to determine which level of a cell a user will be assigned to. So the problem that we are going to solve is to maximize the minimum distance of two UAVs having the same power. Please keep in mind, what is the objective now? The objective is to maximize the minimum distance between two UAVs having the same resource plan. So if these are different cells, and if it uses resource plan A, and if we want to allocate the same resource to another cell, then we have to select a cell that will be farthest from this one. So we cannot allocate here, we cannot allocate here. Our intention is to maximize the distance from this cell, having the same resource plan. So this is a algorithm that I have developed in my research, but describing this will not be interesting, I think. So instead of describing the algorithm, I am going to the simulation. So suppose we have 6 drones. M indicates the number of drones, and N indicates the number of resource plan we have. That is the number of spectrum and power combination. Keep in mind that we are going to use the same spectrum in all UAVs. This kind of frequency reuse is called universal frequency reuse. So we want to use the same spectrum in all UAVs. So we have 6 UAVs and N number of resource plan. So to solve this problem, we want to convert this problem of resource allocation into a new, I would say, domain of computer science. And that is, okay, so we assume that each UAV as a vertex. Each UAV as a vertex of a graph, and the distance between two UAVs is being assumed as an edge between these two UAVs. So this is an edge which represents distance between these two UAVs, and these are different vertices. Okay, so we see that it's a fully connected graph. So our purpose here, suppose we have n colors, say red, green, and blue, and we have m vertices, that is m UAVs. We have to allocate these n colors among these m edge vertices in such a way that the distance between two vertices having the same color is maximized. Okay, this is how we can reduce interference between two UAVs. You can ask me a question, sir, how can we implement this kind of solution? To implement this solution, you can make any of these three UAVs a master UAV. Master UAV, which will collect the location of all UAVs. That is, all UAVs will send their location to the master UAV, and master UAV will implement the algorithm that I'm going to discuss right now. So we want to color these UAVs in such a way that distance among two UAVs having the same color is maximized. Here's an example. In this example, we are assuming 10 UAVs or 10 vertices actually, and only three colors. 3 colors means 3 different resource plan. Where resource plan is a combination of spectrum and bandwidth allocation to a specific subband in that spectrum. These dotted lines are drawn here just for my convenience. It is not required actually. Since we have 10 UAVs, we can start our operation from any particular UAV. You can randomly pick any UAV. So we have randomly picked up UAV 5. Okay, but if you say, so, no, I want to start from here, this will not cause any problem. Okay, so we have 3 colors. Have a look on the right side. Red, resource plan 1, and green, resource plan 3, and blue, resource plan 2. We have to allocate this color among the different vertices. How can I do this? At the beginning, we have not yet used any color, right? So we can choose any of these 3 colors because we have not yet used any color. So suppose I have randomly chosen red. So I have colored the vertex 5 with the red color. Now we have to choose the next target, that is next UAV that we want to allocate as a resource plan. Now how we will select the next UAV? This cannot be done randomly. We have to follow a rule. So from here, you have to find, actually the master UAV has location of all UAVs. So from there, it can check which UAVs among those which has no color is closest with this one. We see that the UAV 4 is closest with respect to the UAV 5. So we select this UAV as the target UAV. Now, which color we can use to color this UAV? We have already used red. So we have left 2 colors, green and blue. Which one we can use? We can use any one between these 2. Suppose we have chosen this one. So far we have colored 2 UAVs. Next task is to select the next target. So if we exclude this one, among all these UAVs, which is located closest to one compared to this one? This is UAV 7. So which color we can use? We have already used red and blue. So we can use green. So far, we have colored 3 UAVs. Now select the next one. We see that from the master UAV, a start flying base station, this is the closest one. Please don't talk. This is the closest one. Which color we can use? Among these colored UAVs, we see that the farthest one is UAV 4. Farthest one is the UAV 4. So use its color to color this one. And to go to the next slide, similar procedure we will follow. Sir, okay. In the next slide, we see that only one UAV is left, and that is UAV 0. Now, how can we color it? Which color should we use? To use color, let us first check green color. Among green, UAV 1, 3, and 7 have been colored with green. And among these 3 UAVs, which is the closest one with respect to 0? It is UAV 1. So select this one. And next, among the colors, say blue, we see that 2, 4, 9, and 7. 2 is the closest one with respect to this target UAV. So select this one. And select this one. And among red, this is the closest one. Now, consider these 3 UAVs and see which one is the farthest from this UAV. And this is red. So, color this UAV using red color. Actually, I have illustrated my algorithm using color here, but when it is implemented or simulated, actually we use only numbers. Okay, and the system doesn't have any pictorial representation like this one. Only you have numbers. This is the simulation results. Sorry, simulation parameters. We simulate in 1 square kilometer area, and the number of UAVs will ranges from 3 to 24, and number of users will be 400, and transmit power per UAVs is 30 dBm, and UAV's height is fixed. But if we want to change it, then one optimization criteria will enter into our problem, and it will make the system more complex. And we have used some other parameters which I'm not discussing here. And baseline algorithm is a network where no SFR is used, and another algorithm which is used for fixed cellular system. So I will compare this algorithm with the performance of these 2 different algorithms. Okay, next is average throughput of cell-edge users. So this is the average throughput per user in cell-edge region, and we see that it is considerably almost 0.75 megabit per second higher compared to the baseline algorithm. So we see it's almost 25% improvement in the average user throughput. And in terms of user satisfaction ratio, which is defined as the number of users who has got its own required data rate compared to the total number of users, we see that a proposed technique can improve the satisfaction ratio by 4.5 times with the no SFR case, and with respect to the fixed cellular system, particularly small cell network, it improves up to 25% satisfaction ratio. And this is dense fairness index, how fairly we distribute the bandwidth among the users. If you distribute whole bandwidth to a closer user, then you will get very high average data rate. But Giving everything to a person and giving nothing to other people is not a solution. So we have to check how fairly you are allocating the resources among users. And we see that the proposed technique, it outperforms all existing algorithms. So it seems that this method is an UTPA method, right? With respect to all parameters, it is doing well. Actually, it is not UTPA method because it has a limitation. It has limitation because its complexity is big O m square n. Big O m square n, where m is the number of UAVs and n is the number of resource plan, which is considerable. And this kind of huge complexity will be a bottleneck for a UAV which has limited processing power and limited battery energy. More computation means more energy loss, and more energy loss means lower operational time of a UAV. So we have to find a solution that will be able to that will be less complex. To solve this problem, we will approximate the algorithm that we develop using machine learning. So first we deploy UAVs. First find the user locations, then deploy UAVs, followed by resource plan allocation via our algorithm, and then take user positions and allocate a resource plan in a data set. This is the whole process. I'm not going into the detail of this process. And we see, in this case, we use two machine learning algorithms. One is deep learning, another is ensemble learning. It's a combination of multiple machine learning algorithms. And we see that ensemble algorithms can predict the required resource plan with 75.85% accuracy. And let us see its impact. This one is machine learning algorithm, and we see that it follows very closely the original algorithm. But even if its performance is very close to the original algorithm, but its computation complexity is incompatible. Few additions are required to implement this whole algorithm. And that's all about the presentation. Now I would like to conclude my presentation saying that in this presentation we have discussed about different algorithms for managing interference among UAVs, and we found that the proposed algorithm can achieve up to 20% higher data rate and user satisfaction ratio. And this is the future research direction. This is the future research direction. If you want, you can work on this topic. Since 6G is quite a new topic, a new research field, so there are many work scope which you can work on. First of all, you can integrate UAV system with integrated sensing and communication system. Actually, in this system, we integrate communication system in radar. A conventional radar can perform sensing as well as communication. So you can integrate these two, and then there will be huge interference. You can develop a solution to minimize interference. Then you can check the impact of UAV speed on throughput, because I think that it will have a significant effect on the throughput experienced by user. And then terahertz channel modeling and holographic beamforming can be used for UAV assisted wireless network. And that's all about my presentation. If you have any question, feel free to ask me. Please. ওখান থেকে বলো। That is a costly. You cannot deploy that. হ্যাঁ, কিন্তু ফুটবল খেলা কতক্ষণ হয়? 1.5 ঘন্টা, 1.5 ঘন্টা, 1.5 ঘন্টা। প্রধানমন্ত্রী যখন কোথাও আসে কতক্ষণ উনি থাকেন? 1 ঘন্টা বেশি থাকেন না? ব্যাপারটা এরকম। কখনোই হিউম্যান রান করবে না, এটা পুরোটা এআই দ্বারা রান হবে, পুরোটা এআই।
স্যার তো তোমাদের সাথে আছে, তো লাস্ট আর একটা প্রশ্ন দেব, আহাদের প্রশ্ন আরো থাকবে। এই স্যার
আমার সঙ্গে দেখা করো।
সুতরাং ইউ ডিসকাস উইথ হিম। লাস্ট কোশ্চেন প্লিজ, বিকজ সবাই হাংরি। অনেকগুলো প্রশ্ন আমার নিজেরও আছে, উই শ্যাল ডিসকাস উইথ হিম। লাস্ট কোশ্চেন, এনিওয়ান?
ওখান থেকে মুখে করো, দরকার কোশ্চেন থাকলে। এটা কোশ্চেন করাচ্ছে, এখন খাওয়াটা বেশি গুরুত্বপূর্ণ স্যার। সো নো কোশ্চেন স্যার। থ্যাংক ইউ।
Thank you, sir.
Thank you, sir.
Thank you, sir, for delivering us information about this topic.
Okay, sir. Thank you, sir.
So তোমরা পরবর্তীতে যারা অ্যাভিওনিক্স কমিউনিকেশন এবং সেন্সরস নিয়ে কাজ করবা, you have a resource person here, so be engaged with him. Thank you very much once again, Dr. Sakir, and please respond to the students once they come. Okay, and now hand over the master of ceremony.
Thank you, sir. Thank you once again to our incredible audience and our fantastic guests for joining us today. We hope we have had a memorable time and enjoy every moment of this event.
As we come to the end of today's program, I would like to express our deepest gratitude to all the guests, keynote speakers, distinguished professors, faculties, volunteers, and our amazing team who worked tirelessly behind the scenes to make this event possible. Especially thanks to our distinguished professor, Air Commodore MD Afzal Hossain sir, Dean of Faculty of Aviation Engineering Technology, MD Mukhlisur Rahman sir, Department Head of Aviation, Avionics, Dr. MD Raju Rahman sir, and Assistant Professor MD Samir Rahman sir, for taking such initiatives and to make the seminar successful.
We look forward to seeing you all again at our next event. Until then, stay safe and keep spreading the positive energy and inspiring we have shared here today. Goodbye and have a wonderful day. Assalamu alaikum.